Good. All right. So we started lesson two yesterday. So we're a little bit ahead, which is always good because we've got plenty to get through. We were talking about um, consensus. How do we decide about a particular block, and how do we come to agreement about that? And I spoke to you about one of the families of consensus mechanisms, which is the BFT family. And so Solana has their version called, well, a derivation of a particular type, but called Tower BFT. So with this, it's dependent upon validators voting upon the blocks that are being passed to them from the leader. But the validators will be making a simple yes or no vote, and if a uh, block has enough votes, then that will be accepted. There is this question about timeouts, and this is where, again, the proof of history, this kind of clock that they have becomes useful because it allows us to make decisions um, uh, about timeouts more easily and do that in a decentralized way. So we're able to do that. And um, yeah, so once two-thirds of the validators have agreed, then that becomes canonical, and that is that's the canonical part of the chain. Right, yeah. So Alpenglow. So this is something that has really just been proposed. So it's to update the way that the consensus mechanism works. And the original design of Solana, it happened quite a long time ago, and there were a number of innovations that they had, a number of pieces to the design of Solana that were brought in really because of scalability. And if you look in the documentation, there's some good articles about all of those. But over time, obviously, people have got more experience and understanding of how things worked, what's done well, what hasn't done so well, and they've come up with some updates, some new ideas. And the latest one is the Alpenglow, which is trying to replace some aspects of the consensus mechanism. And I think in particular, what they are uh, trying to do is to look at finalization to try to improve that. But some of it, I think, is more a case of really extending what we already have. It's not that the existing things are working badly. It's more sort of tweaking them and trying to improve them. But all of it is trying to get better throughput, get more transactions going through the system, and also, as I said, to help with finality. So you can see there the to try to get finality within 150 milliseconds or 100 milliseconds. That's extremely fast compared to 10, 12 seconds that you would have otherwise. Uh, I should perhaps at this point say something more general about this movement or this motivation towards improving the scalability. Obviously, it's a very understandable. I'm not criticizing it in any way, but I do wonder what. I think again this applies to all blockchains, but I do wonder what is an acceptable amount. What are acceptable values? And I think it's something worth questioning, worth thinking about. What would be an acceptable value for finality? What is an acceptable throughput if you're thinking of transactions per second? And I think that's something worth considering because all blockchains, you find that they will talk about the number of transactions per second they can get through the system. But I think it's worth wondering if there's a point that we will say, well, that's enough. We've got enough throughput there, or is it going to be something that we will always be trying to improve and to get more throughput? And particularly, I think in terms of if you look at trading systems, financial trading systems, it may be that people will be able to soak up the increases and just do try to do faster and faster trading, and this will take up all of the increases and all of the benefits that we get from tweaking the consensus mechanism. But we shall see. But certainly, to get finality like this, 100 milliseconds is going to be impressive when that happens. Just points about this where looking at the idea of the fault tolerance aspect of this and how they have done this, because when you are creating the consensus mechanism, well, if it's based on BFT, then you are looking at a certain amount of tolerance and the amount of misinformation that you could have, or lack of information. So here they are quite explicit about that. So they're saying that this is still going to succeed even if 20% of the stake. So this is talking about the validators having a stake, and so we look at it in terms of the stake here. So if 20% of that is controlled by attackers, we will still be able to proceed. And also, if another 20% of the stake is offline, if that's not responding, we will still be able to proceed, which is quite impressive in terms of the percentage there. Okay, so that's the latest thing. It is formed of two parts as the rotor and voter, and I can dig into those in more detail later if people are interested in finding out more. Okay. So I'll just quickly mention a little bit about the history of Solana. Having said that it was designed quite a long time ago, 2017, and by this time, obviously there was quite a lot of expertise and experience that they could draw upon. Obviously Bitcoin had been around for almost 10 years. Ethereum had been around sort of, well, 3 to 4 years, I guess, at that point. And so they could look at the way that those chains were working and look at the problems they have, and then use that to design something that was better in terms of, certainly better in terms of throughput. And the background of the founders for this, like they came from a background, I think, to do certainly with developing, I think, mobile systems and working on operating systems. So they had a very technical, very in-depth background, and they were able to use that experience also to help design Solana. So it started out, 2017, initially called Loom, but then there was another project called Loom, so they changed the name. And over time, they managed to build up the number of the throughput that was happening. So getting to 10,000 transactions per second, and then more. Whenever I see figures like this and people talking about transactions per second, I always want to think about the context that this is being done within. And you need to query this and think about, well, is this on a real network where there are potentially adversarial nodes and maybe misinformation? Is this, what size of network are we talking about here? Is that going to scale? And also the types of transactions that are being put through the network, are they representative of the types that we would be seeing when the network has scaled up generally? Or they could possibly be something very simple. So you should be thinking about all of these questions. And perhaps I'd never take these figures to be exact. Maybe I'd take them as an indication of things improving. But you can certainly see that here anyway, that over 2018, they were improving and building up this test network and really showing that this approach was succeeding, and that they could get a lot of transactions through the network, but also they could increase the nodes as well, and still keep a reasonable number of transactions, or quite a high number of transactions going through the network. And just to mention a little bit about scalability quickly, there are trade-offs. There's a thing called the scalability trilemma that is more of a rule of thumb. It's not an exact law or sort of computer science concept, but what it's saying really is that there is a trade-off that people make with blockchains when they're designing them. Uh, and if you want increased scalability, then you may have to compromise on either security or decentralization. So, for example, if you reduce the number of nodes in your system, this could give you better scalability. But doing that is adding centralization to your system. So there's a trade-off to be made. But anyway, the it's yeah, it's sort of going well. They got good throughput, good response. We got bridges launched, so we'll see exactly. We'll talk more about Wormhole later, but we got bridges between Solana and Ethereum. Um, it was affected, and I think disproportionately as well, by the collapse of FTX, sorry, um, which yeah happened 2022. Obviously, that affected all blockchains, but I think it particularly it hit Solana quite hard. But it certainly recovered, and we saw within 6 months it has recovered quite well, I think. We saw then also the phone being made available. So the idea there is that the your wallet is very much integrated into the phone, and the it's really to provide you with a very good Web3 experience. The idea that everything is going to have some aspect of Web3 and do that seamlessly. And then, yeah, as I've just mentioned, we're starting to see different tweaks to the consensus mechanism coming in as well. Okay. All right, so that's a little bit of the history. Let me talk then about the community. And again, we'll certainly come back to this before the end. But one of the strengths, I think, in Solana is the community. There is a very vibrant, very active, very strong community. They have all of the usual social media channels that you would expect. But also, there are many groups available to allow you to meet up with fellow developers. And I would definitely recommend you get involved. If you're going to start developing on Solana, then go and find other developers. Look around wherever you're based in the world. There will probably be a local community of Solana developers, and they're well worth. It's well worth reaching out to them and making the most of their experience, and also just the benefits of working together and getting to know other developers. Within the calendar, there is a major conference each year called Breakpoint. I have to say the Solana events are always amazing. They put a lot of effort into them and give. They really do give a lot. Um, so, well, if you got a chance to attend, I would, yeah, certainly recommend that you do that. And if not Breakpoint, then there are other events as well. So I've got another screenshot here from the events page. So you can see that there's events all over the world happening, Singapore and Mumbai. There's lots of things happening all of the time. So keep an eye on those and really go along and enjoy these. They're uh, well worth going to. In addition to that, they've got something that is reasonably unique, I think, with Solana. They've got this idea or this concept of super teams, which are local communities that are very active, local communities of developers that are very active. And you can see there's again screenshots showing you some of them in different parts of the world. So wherever you are, you'll probably find a local super team to engage with, and they will be able to help you with development. Generally, they have resources to help you. They organize all sorts of things. So yeah, do get in touch with them. Now, if you are interested in looking at the Solana protocol itself and the ecosystem, then there's also the Solana Collective that you can get involved with, and that if you're interested in doing that or want to get involved, then that allows you to work with some of the core teams there. There are grants available as well from the Solana Foundation. This list of initiatives is a little old, I think, but it gives you a general idea of some of the areas that they were looking at in particular. But having said that, I would say that it's always worth applying for grants, and that uh, I mean, you should have a good idea, in mind, and something that is valid and feasible, obviously. But even if they're unable to give you a grant for whatever reason, um, they will probably be able to help you in some other way. So maybe they'll be able to point you at other resources that would help you go forward, or maybe they would be saying to you, well, we, we're not going to give a grant for this because this thing already exists, so go and talk to that team, and they may be able to help you like that. So it's always worth applying, and getting to know the Solana Foundation, and finding out what they're looking for. Yeah, it's going to be useful for you. I think you'll definitely get something out of it. And then also, from super teams, they have opportunities as well. This is done from the UK super teams. They have these bounties that they give. So different companies and projects will give bounties for you uh, to work on the ecosystem in some way. So this is quite wide ranging in the things that they will give bounties for. So sometimes it could be development, so it could be writing a program. Sometimes it could be around tooling, developer tooling, or helping the developer community in a technical way. Quite often it's around marketing, as you can see here, things like writing articles or sending out tweets, etc., about projects or aspects of projects. So there's lots of things that you can have a look at there, and also there are hackathons as well that they will be promoting, and they often give the details of the bounties that people are offering in the hackathon, so you can see there if there's something that you can aim for also. So yeah, more great resources. So have a look at those, and of course within code as well. Keep an eye on the hackathons, because there may well be something there that you can get involved with. All right. So that's, yeah, a little bit about the community. I'll probably revisit that towards the end of the course, just to remind you and just to give you some updates. But that's yeah, that's a little bit about it. Okay, now I'm going to come on to a new topic. So I haven't said anything about this before, because this is, a relatively new area, about vibe coding, and it's something that we do get asked about a little bit, and it's probably something that most of us are actually doing to some extent. We are probably using AI agents or large language models or whatever to help with our coding to some extent. And on this course, you obviously you can use whatever tools you want to get the most out of the course. But one thing I would say to start with about that is that for this course, we want you to build your skills. So it's all about getting you up to speed and skilled in developing on Solana. That involves, building skills involves changing your brain, essentially. And for that, you need to make effort. So uh, it's okay to use whatever tools you want to help you with your development, but you still will need to put effort in. It's still about building those skills, and the skills are probably going to be more than just knowing a good prompt to use with a large language model to get some code. So there's more to it than that. So although yeah, it's okay to use those tools, obviously, but there is a little bit more to what you can get more out of the course than just using those tools. So we have this concept of vibe coding, and I wanted to sort of look at some of the advantages and disadvantages of this, just to make you aware when you're using these tools. So they can be very good, particularly if you've got an idea and you want to try it out, and do it fairly quickly. I mean, that's the whole idea of the vibe coding, is that you can get something developed and get code written very quickly before you're kind of out of the moment, and you've forgotten what it is exactly you want to do. So without overthinking, and if you're doing hackathon, something like that, that might well be a great place to do that. And it helps you, yeah, maintain momentum and enthusiasm, helps us avoid the getting kind of blocked with things, as you say, that there's all the blank page anxiety, where you kind of got a blank page in front of you because you don't know quite where to start. You've got lots of ideas, but you're not sure which one to start with. So it can be useful for that. It could also may throw up new approaches and suggest things that you haven't thought about, and it can just be make it more fun. But on the downside, I would say it's certainly could bring up technical debt. So you may get some code that in a limited way will do something useful. But when you want to expand on that, when you want to actually build a project and a production system, then you may have got some technical debt that you're going to need to work through with that. Things like scalability, that may not be something that is going to be easy to for the tools to think about, initially. And things like the good developer practices, like good documentation, that's probably that may well not be there. Although the tools do add documentation into the code, but it may not be quite correct. It may not be quite appropriate, and there could be inconsistencies, particularly if you're doing this over time and the large language model has lost the original context. Then you could have inconsistencies in the design of your code. Uh, and then it may not, although you may understand because you've remembered what you were doing, it could be more difficult if you're collaborating with people for them to understand how different pieces of code fit together. Um, there could be bugs introduced. It could the scope may not be well specified when you're doing this, and yeah, it's probably not going to know enough about performance to make a good job of that. And one analogy I like to think of when I'm using these tools is that of an autopilot in an aircraft, where yes, it can be very useful to take away some of the mundane activity, but you still need to know how to fly the aircraft. You still need to know how to work without that, and how to check that the code that you've got is correct and that it's not doing something that you don't want it to do. So that's so certainly learn and understand the theory and build up your skills so that you can do this yourself, and then use tools such as large language models, whatever you want, to take away some of the mundane tasks. And we'll also see later on, I mean, the way that we built this course, we later on we look at this framework called Anchor, which is there to take away some of the mundane sort of boilerplate that you don't want to necessarily have to repeatedly develop yourself. But before you do that, it's good to know how that all works and to understand the rationale behind that. So that's my ideas about vibe coding. Yeah, you'll have your own views, but anyway, there you go. And interesting, I actually asked large language models to give me some of the things that I used here, and I asked three different ones. Two of them made a reasonable job of it, and then one of them went completely off topic. So it does show you that, yeah, they're useful tools, but they can sometimes go completely wrong. So do be aware of that, and do check the code that these things come out with. All right. Okay, so moving on. Let's talk about Rust. So what we're doing is we're going to assume that you're new to Rust, and so we're going to teach you Rust. And the uh, we will teach you enough Rust so that you can write the programs for Solana. Obviously, there's going to be more advanced topics in Rust that we are not going to cover that are probably not relevant. You may not need them. We're going to give you hopefully enough so that you can really concentrate on developing in Solana. What I would suggest is that you try some of these things out. I forgot to open this. So this is the Rust Playground. So it's quite a nice little tool. So you can write code in here and then quickly check it out, quickly build and run it, so you can see how it's working. Now, Rust is quite a popular language. It's quite well thought of, I believe, amongst developers. And there are a number of reasons for this. One, I think, is that it has quite wide scope. It is used in a lot of different areas. So it's good as a kind of a general purpose language and for writing sort of general purpose applications. But you also find it being used in embedded systems, for example. So it can be a very performant language as well. And so it's typically speaking, I would say it's a very good idea to be familiar with Rust. And one area that I've seen this in as well is with zero knowledge proofs. So there are zero knowledge proof systems that have languages associated with them. People have written and developed these languages specifically for those systems. But what we've seen is that for most of those systems that you see in the Web3 world, they've based that based the language design upon Rust. So having a knowledge of Rust will give you a start with those areas as well. So it's a good choice, I think, for as a language anyway. But it's I think a very enjoyable language. It is a little bit different to some of the other languages or the mainstream languages that you may have seen. And this is mainly to do with some of the rules that it has to enforce. And the reason that it needs to do this is to do with the way that memory works. And uh, so within a language, when we're running a program, we will be using variables, and these may be very simple items. They could be just simple integers, something like that, or they could be quite complex. They could be structures, quite complex objects, and depending upon the complexity, they are stored in different areas. So what we're particularly concerned with are when things are stored on what is called the heap. So this is a general area of memory where we can store large objects that are being used within our program, and then they will be accessed in the code. Now, one point about general languages is that yes, we can do that, but that area of memory very quickly will fill up if we don't do something about it and we don't have a means to do some kind of recycling or what is called garbage collection. It would fill up very quickly because in most programs we do use a lot of variables and store a lot of data. And so we need some way to make sure that what is in the memory is not has not been just left around, and we need to make sure that the things that are in the memory, the objects that are in memory, are still being used, and that that old things that are no longer needed can be cleared out, and we can free up space for new items. Now, different languages have done this in different ways. Some of them use something called a garbage collector, which is a special program that runs in the background and will effectively stop processing and go through memory and clear out items that are no longer needed. So that does work, but it does mean you have this overhead. It does bring in the overhead that your program has to stop while the garbage collector goes in and works out what can be removed, etc. So Rust has taken a different approach where they don't use garbage collection in the same way, but they still have a way to know within the memory the lifetime of objects and when items in memory can be overwritten and when they're no longer needed. So that is what I'm talking about with memory safety. And in order to do that, the Rust language imposes some rules on us so that we have to write our programs in a certain way so that it can do this process of knowing when items are no longer needed and therefore they can be overwritten. This also applies to concurrency as well. We need to be careful about concurrency. If we have multiple threads trying to update something, we have to make sure that that's being done correctly. And this has to all be done in a way that is abstract enough, but without providing a sort of performance problems, sort of overhead as well. Sorry, let me just quickly look at the questions. Okay. All right. So variables. So we need obviously variables within our program, but similar, perhaps slightly similar to functional languages, which where the variables there are typically immutable. That's also the case in Rust. So by default, once you've declared and assigned something to a variable, then you can't change that. If you want to do that, you can specifically say that this is a variable that will change over time. And to do that, you use a modifier, the mute modifier. So as you can see here in this code, we've started off, we've got a variable x, and that's going to be immutable. And if we want a variable to be mutable, then we have to use the keyword. So y here is mutable, and we can effectively mutate that later. Let me just quickly show this in the playground just to show that hopefully that works. There you go. So you can see that y started off as 5, but because we declare it as mutable, then we can change it to 6. Okay. Oops. So that's the general point about variables. Types, I'll just mention these quickly. Obviously, if you want to go in more detail, then look through the documentation, and I've got a link there to the Rust book, so you can have a look at the different data types. But this is a general purpose language. It does allow us to, it does give us the, quite a wide range of data types, as you can see. Let me just quickly see if these are all going to work. Hopefully they will. Yeah. So you can see here, we've got some different data types. Now, really, the compiler needs to know what the data types of a variable are, but it can infer those. So, for example, on this line here, we're saying that this is an unsigned 8-bit integer. And we've made that explicit. The line above, we haven't said what the data type is, but the compiler can work that out. So it'll make a reasonable guess about that, and therefore you don't need to be explicit. If it can't make a good guess for that, then it will throw up an error to say that it needs you to specify what the data type is, because maybe there's some ambiguity or something like that. But the way that you do that is you follow the variable by a colon and then you put the data type. So you can see here we've got unsigned integers of various sizes, so 8-bit going up to larger sizes, and then we got here floating points, 32-bit floating point. You can have 64-bit as well. We can have booleans, true or false. We can have characters. Yeah, so you see that's a range of data types there. And yeah, scalar types, these are the simple types representing a single value. things like integers, floating points, booleans, characters, so the ones I showed you there. We can change the size of these, so you can have a size appropriate to the data that is going to go into that variable. So it could be 8-bit, 32-bit, 64-bit, etc. Then within the floating point data types, we can have 32-bit or 64-bit sizes. Nowadays we usually have 64-bit. That's what modern CPUs will be able to handle easily. I've already mentioned booleans, which are true or false, and characters. So this is a value that represents a Unicode value, but it's not a numeric type, so we don't easily move between types in that way. Other things you may see, one is usize, and this is maybe a little bit more advanced, but it's because you may be compiling for different architectures. So, for example, if you are compiling for some embedded system that has a different architecture, then it could be that the size of the pointers that are going to be used is restricted or different from what would normally be used, and therefore usize is used for that, so that you know you can use that when you're writing your code to represent the size of the pointer that it's eventually going to compile to. Now, those are simple types. We can put these simple types together to make more complex types, such as creating tuples, arrays, structs, and enums. So tuples, I'm sure you've come across these before. These are just putting together some items, and these can be of different types. So you can see here within this code, we've we declared a variable x. We're specifying the data type. So by putting it in parentheses here, we're showing that it is a tuple, and we're specifying the data types of the items within that tuple, and then we're doing the assignment of those items. So we're saying that this is going to consist of a 32-bit integer, 64-bit floating point, and an 8-bit unsigned integer, and then we've got examples. Then we assign numbers, numeric literals, to those. So that's setting it up. When we want to reference the items within the tuple, then we use the dot syntax. So here you see you can use the .0 to refer to the first item, .1 to refer to the second, and .2 to refer to the third. As you can see there. And let's see if this is going to print out. We'll try this in the playground. Yeah, so you can see, yeah, they're again using the dot syntax there to print out the items that we've got. Now, you'll see that in this, we've got the I32, which we've come across before, excuse me, but we've also got this strange thing here, this ampersand str. And I'll talk about it a little bit later. This is a type of reference, and we often use this when we are using strings. So this is a common way that we would, a common data type that we would have for a string literal, as you can see here. So this is the string literal Rust. Okay, but I'll explain more about this in a second. So that was tuples, quite simple. We can make this more structured with a struct. So for that, use the struct keyword, you give it a name, and then you specify the fields within the struct. So this particular struct has 3 fields. They have a field name, so that is name, age, and email. And then again, we specify the data types for those. So this struct is going to have a string, a U32, and another string. And when you declare this, what this does is to really effectively create you a new data type. So you can then later on use create a variable of this user data type and then access the fields within that. So it's a way that you can build up things into useful objects, useful structures. I'll talk about Impl a little bit later, but just to point out, this struct is being used. It's being initialized here, so it's being created here. So we're creating the struct by using the name of the struct, and then within curly brackets, we're specifying the different fields within the struct. As you see there, I'll explain some of the complexities here, what the into is about, etc., a little bit later. But also then you can see that it is later used in this function to print out the details. And again, we're using the dot syntax to reference the different fields within the struct. Okay. Now, if you're used to other programming languages, you've probably come across collections within languages. And one of the most common, one of the ones that's very widely used, is a vector. And this allows you to set up a collection of items of the same type. And it's similar to an array, and we'll look at arrays in a moment, but it actually gives us much more flexibility than an array. We have lots of methods around the vector. And what this piece of code here is showing you is the creation of a vector. So we're creating a vector and we're assigning that into a variable called names. And the way that we create it is shown here, this vec exclamation mark. Now, when you see an exclamation mark, that means it's a macro. And again, we'll talk about those later. But this is a convenient way to create a vector by using this vec macro. And the way that it is used, where we use this macro, is when we actually have some items to put into our vector. So when we already have the items that are going to go into our vector, then a convenient way to do that and to create the vector is to use the vec macro. And as you can see here, that is using 3 string literals, so 3 names, and it's going to create us a vector, a collection of string literals, and it's going to start off with these 3. And you'll be able to add to the collection later on, but that's what we're starting with. It's also possible to create an empty vector, and we'll show you how to do that later. So yeah, we've just seen some strings. These are similar to what you'll see in other languages, but we do have this special type here, this ampersand str. This is widely used, but I'll leave the explanation of this to when we look at references in a moment. The other thing that we can have is a string, and this is something that can grow in size. It's mutable. This will always live on the heap, and so therefore we have there are special rules about how we can use string alongside all of the other items that are on the heap. So we're going to start to look at those in a moment. Okay. I said I briefly mentioned arrays a second ago. So these work in the same way, pretty much the same way as in other languages. You have objects of the same data type. These are stored together in memory, so that means it's often quite an efficient way of storing items. We use square brackets when we are interacting with arrays, but one feature of Rust or arrays in Rust is that they are static. So once you've created an array, then that you cannot change the size of that array. So an array, once it's been created, will have a certain length, and that length cannot be changed. So you can't add or remove items from your array For something like that, a vector may be a better choice. Yeah, you access them via an index, just in the same way that you'll have seen that before. Now, I said you can't remove items from the array, and you can't, but you can. It is possible to modify them. So um, as long as you don't change the length of the array, then you can change the items that are within the array. And I've got some examples here of uh, declaring arrays. You've got quite a few options to do it in different ways. So you can do it with some literals. So you can see here we've got the numeric literals 1, 2, 3, 4, 5, and we're creating an array based on those. You can also specify a data type if you want to. So here we're using the colon syntax, and then within the square brackets to show that it's an array, we're saying what the data type is, and we're also specifying the length of the array. We can also provide a default value for elements. So you can see in the next one here, we're saying that we're going to create an array. It's going to have 3 elements, and they're going to default to the same value, which is 0. We can create mutable arrays. So again, that means we can change the element within the array, but we cannot change the size of the array. So with this mutable array, we can't remove the elements, but we could change those specific values at the different indexes. Okay. Now, another possibility you have, something similar to arrays, is a thing called a slice. So these give you a little bit more flexibility because you don't have the length specified at compile time. So this is specified, this is variable at runtime, or specified at runtime. And there's some links there to more details about slices if you want to have a look at those. Okay. All right. Numeric literals, we've already seen those. I think they're very straightforward. But one nice thing is that you can use underscores when you're writing them to make them more readable. So that can be quite helpful. Byte literals, you can use ASCII code, as you can see there with within apostrophes. You can't easily convert between types, or it's not done implicitly. So if you want to do that, you have to be explicit about that. And to do that, you use the as keyword. So you can see an example there. So let's have a look at enums. Again, quite a common language feature. I think it's a very useful one. It allows us to set up some possibilities for an item, and it makes things very readable. So you can see here we've got this thing fruit, which could take values of apple, orange, or grape, and then you can specify which one of those it's going to take by using the double colon syntax there. So we say fruit, double colon orange, and then that's the one, that's the value that it has. It means that when you're writing this in your code, you're restricted to those values, and you'll find out if you're trying to use a different value that doesn't exist, then it's going to give you a compile error. Okay. Functions, very straightforward. They start with the fn keyword. Then you have a function name. Then you have some parameters. So there's a variable, and then you will specify the data type for that, as you can see there. And then we have an arrow followed by the return type for the function. So here we've got a function that is going to return a Boolean. Okay. Now, the first part of this function seems to be doing that okay. So you think this is maybe what you have seen before. But then we've got this line here, the final line in the function. And that may be a little bit confusing because we don't have a return keyword there. So what's actually happening? Well, with blocks of code, what you can do if you have the uh, final line, the value of that will be the return from that block of code. So we don't need to put a return here because it knows that the return value from this block of code, from this function, is going to be given by this piece of code. So this piece of code is testing whether a is equal to 7. So it's going to return a Boolean, a true or a false, depending on whether a is equal to 7. So we don't need the return there because it's the last line in the code block, and we don't need a semicolon either. So that's why this looks a little bit different. Of course, you can return from a function earlier, which is why we have on this line, we do use the return keyword because we want to be able to return from the function, but this isn't the last line in the function. So we have to have a way of doing that. Okay. All right. So loops, we have a lot of choice about loops, the way that we can specify them. So there's some examples here. You can use the in syntax and have different ranges and including or excluding different parts there. You can also take steps within the loop, as you can see there. Also, you can use loop, which will just keep looping until you hit a break keyword, or you can have while, which will loop until you hit a specific condition. And yeah, have a look at the book, the documentation for more examples. Okay. Control flow looks straightforward. It is very similar to things you'll have seen before, but there's a couple of slight differences. So we have if, and that is going to be followed by a condition which must evaluate to bool. So it's not the same as some languages where you can put some numeric value in there and that will work. You have to have something that is going to result in a bool. So you can see in this first piece of code here, we have a condition where checking whether x is less than 4, so that's going to return a true or a false, and so we can use that with our if. And we also have an else, which goes with the if, just in the same way that you'll have seen before. Now, what is a little bit different about if in Rust is that it is an expression rather than a statement. And so because of that, it will return a value. So you can get things like this line here. So let's unpack this a little bit. So what we're doing on the previous line, we've set up a variable, a bool called condition. And then on this line here, we have the if to check that. Obviously, in this case, it's hard coded, so it's always going to evaluate to true. But what we do then is we go into this code block here. Obviously, if it was possible to get a different value, we could go into the other code block. But in this case, we're going to go into this code block. The return value of this code block is 5, which means that that then is the return value of the if expression. So the if expression is going to then be equal to 5, which means that the value that we assign to number is going to be 5 because that's the value of the if expression. If you had something more complex and the if could evaluate to something else, then obviously it would return a different value, and then that would get assigned into number. Okay. And we also have else if, as you see in other languages. And printing, so something that's very useful when you're developing and debugging your code, trying to work out what's going on, is the ability to print out variables as we're going along. And so we have a number of macros that will help us with that. The most commonly used is the print line here. So this will print a line and then give you a return, a line return. And so you can put string literals in there. you can make things a little bit more flexible by allowing placeholders. So what we've got here, if the curly brackets here represent a placeholder, and what the macro will do will be to find something to put in that placeholder, and the thing that you're going to put in the placeholder you add afterwards. So you do a comma, and then you add the item that's going to go into the placeholder. So in this case, this is going to print out 19 tokens. Okay. I'll talk more about the different options or the different possibilities about printing in a little bit later on. Okay. So now I want to talk about something that, well, we do get this in other languages, I think, but it is very useful in Rust. It is very widely used, and it is something that you're encouraged to use, and you're encouraged to use options and results. So the very some structures that are very similar. They will really make your code much better designed if you use things like this. But I'll explain to you what they mean first of all. So it's an enum which is defined within the standard library, so it's available to you to use within your code. And there are two possibilities for the option enum. The first possibility is none, and this is used to indicate maybe something, so there's been a failure or there's not a value where we would normally want a value. The other possibility we have with option is some, and this is a tuple struct that wraps around a value. So most of the time what we want is our option to actually be holding a value. In that case, the option will be equal to sum wrapped around a certain value. So we will create the option and put in a value into the sum possibility of the option to show that that is what we have. But imagine you have a function that is going to return some value. Now, you could, of course, just have it returning a numeric value or whatever type of that value, but you would want to allow for different possibilities. You want to allow for the fact that that function may not have a value to return because of the whatever it has been doing. But you don't want to, it would be nice to have a common return type, a common function signature that could handle any type of possibility. And so for that, having a return type of option is quite useful. It means that we can, in our code, we can say our function is going to return an option, and we know that that caters for two possibilities. Either the option is going to be none, which means there's no value being returned, or it's going to be some. And if it's some, then we have a way to get that value out of the option. And this is quite good because it means we don't have to allow for null values. This ends up, if you put code in to allow for that, it often gets quite complex, quite messy, but option is quite a neat way to handle those possibilities. All right. Now we can actually take that even further, that idea, with another enum called result, which says that, again, if we think about maybe a function is going to return something, perhaps the function is going to return a value, or perhaps it's going to return an error. Maybe an error happened within the function. So the two possibilities within the result enum are, excuse me, OK or ERR, error. So if it's OK, that will wrap around a value. So we can get the results back from a function, and if it is OK, then we can read out the value that is within the result. But if we get back the result and the enum value for the result is ERR, this means we've got an error, and we can read out the error from that. But either way, we've still got a common way of still common return type from our function. So it makes our code more readable, much neater. Okay. Now, I'll go on to a way of coding that is very useful, and I would definitely recommend you think about this and try to use it when you're writing Rust. It really it allows your code to be quite expressive and quite neat. It works very well in Rust. And this is the idea of matching. It is similar to, we do get similar things in other languages, things like switch statements, but within Rust, it becomes very powerful and much more expressive. And the general syntax we have for this is that we have a block of code which starts with the keyword match. Now we match against a value, so we're going to add a value into our match block. We're going to put a value into that. It's going to be a variable. And then we have a number of patterns that we're going to try to match against. So we're going to take that value and then we're going to try to match it against the patterns within our block. And if it does match against one of the patterns, we then follow the arrow and we carry out the expression on the right-hand side of this line. This line is called an arm within the match block. So you carry out the expression that is on the right-hand side here, but only if it matches that particular pattern. So the easiest way to explain that is with an example. So I've got an example here. And what we're doing is we're taking in a value that is of a particular type, and it's of an enum of that we call coin. So we're taking in this enum, which could be any of the possibilities within that enum, and then we're matching against that. We're matching that against the various possibilities that we have. So the first bit of code here is just setting up the enum. So that shows us the possibilities for our coin. So it has four possible values that it could take. And then within our function here, we're going to take in a variable. The data type is coin with a capital C. So that means it's this enum type. And then the variable itself is called coin lowercase c. The function itself is going to return a unsigned 8-bit integer, which is given as a value for this coin. So that's what our function takes in, and then we enter the match block. So we're matching against this variable, this coin lowercase c, that we have put into the function. And here are the patterns. So you can see on the left-hand side, we've got the different patterns that we're going to try to match against. And on the right-hand side, we've got expressions depending that we're going to run if we match. So if our coin variable here matches against the first pattern, so if it's a value coin penny, then we're going to do this expression 1. If it's nickel, we'll do 5. If it's dime, we'll do 10. If it's quarter, we'll do 25. So that matching, I think, is relatively straightforward. You can see that we're matching this coin lowercase c against these patterns, and these are all of the possibilities that we have within the enum. So we've covered every possibility that we could match against. Now, explaining the expression on the right-hand side, what we're doing is we're providing a numeric literal. Now, if you remember, I said that the value that this numeric literal is going to be the return that we get from this match block here. So if you match against one of these, say you match against dime, then the 10 is going to be the value that is the expression that we follow, I suppose, and then that is going to be the value that we get with our match block. And within the function, this match block is the final line within the function. And so therefore, that is the return value of the function as a whole. So that's why it returns the U8, because we're returning either 1, 5, 10, or 25, and that will fit into a U8. Okay, I hope that makes sense. Please do ask about this. It's important that you get the hang of this, because we're going to go on to more complex examples in a moment. So if this is not obvious, then please do ask about this. Okay. All right. So let's take it a little bit further. So here we were doing a match, and the thing we were matching was an enum type or a venum called coin. Let's try matching against an enum, against an option enum. So if you remember, let me go back. Option can have two possibilities, none or some. So that's what we're going to be matching against. So here we have a function here, which we're calling +1, and this is the function which is going to have our match block. Now, the syntax here looks a little bit odd, so I'll talk you through it. But we have a function name, that's straightforward. We have a variable x, that's straightforward. We have a colon, so we're going to follow it with the data type. The data type is option. That's okay, we've come across option. Now we've got these strange angle brackets, which we haven't come across and I haven't explained yet. I will come onto those a little bit later. This is generics, so it's really specifying the data type that we're going to wrap within our option. So what it means is this option, or options generally, they could wrap around any data type. But in this case, they're going to contain a data type I32. So it's just a way of narrowing down the data type that this option will contain. Okay, so that's what we're passing into this function. And in fact, we pass that in, and then we also use that as our return value. We return an option as well. And then we do some matching. So we match the value, the variable here, x, against two patterns, none and some. And you remember that those two possibilities are the possibilities that option can take. An option will either be none or it will be some. If it is some, it will be wrapping around a value. It will be a tuple containing a particular value. So if if the x that we've got here, if that option was equal to none, then we're going to return none. So that's very straightforward. But what about this line here? We've got something odd going on here because we've introduced this I variable. And this is introduced as part of the pattern matching. And what we're saying is we're going to try and match against this pattern. But we've got a variable in this pattern. And we know that when we're doing the matching, that our sum is a tuple that wraps a variable. So what this pattern here does is it will match against sum, and it will take the value that we've got within the sum and assign that to this variable that we've got called I. So we've just decided on putting this variable within the pattern. It's not, we haven't got this variable elsewhere. It's just part of the pattern that we're using. But it means that gives us a way to refer to the value that is enclosed, that is wrapped by the sum that we have in our option. So what we're saying is that this pattern here is going to match against sum. And in fact, because it's a variable here, because this is an I variable, this means that it will match against sum no matter what variable it is wrapping around. Now, you could, as we'll see, you could restrict this. You could try to make it so it will only match against sum with particular values, and we'll see that later on. But in this case, we're not using the variable here really to decide upon the matching, so much as being able to extract the value from the option that we have, that we've passed in our variable x. So what it means is that if we do have a value within our option, then it's going to be a sum, and it's going to be wrapping around a value. This I variable here will extract that for us, and we can then use I to refer to that value. And so when we do the expression on the right-hand side, we create sum, but there we are wrapping around a value of I plus 1. So you can see how matching has suddenly become much more functional. We've allowed our matching to do some extra processing here. We're allowing our matching to actually increase the value that we've got in our sum. And as before, because this match block is the final item within the function, then whatever the match block produces is going to be the return type of the function. So it will be either none or it will be sum wrapped around a value. And that's reflected in the return type that we've specified here. I do appreciate that it's confusing. So I would work through the first option here, this matching. We're matching against this enum, these possibilities, and these are the patterns that we've decided to match against. And then we're taking this further in this example by introducing a variable that allows us to extract an item that was within our sum, so that we can then use that in the expression on the right-hand side. And if you look at how this code is, or how this function is used, you can see that down here. So we start off, we create sum wrapped around the value, the numeric literal 5, and assign that to this variable 5. Then we pass that value into this function, and this sum of 5 will go into this function, and it will try to be matched. Now it's a sum, so it won't get matched against this arm of the match of the match block. It will try and match it against this arm. So we've got sum, so that matches against the sum. The 5 will match. It will get put into this variable I, and so we will do this expression here. So we'll get sum of I, which is 5, plus 1, which means we've got sum of 6. So the return of this plus 1 function is going to be 6 in this case. So this here will return 6, and we put that into our 6 variable. And then on the last line here, you can see what happens if we send in none to this function. So we have this, the option enum, the particular possibility of that is none. We pass that into this function. It goes into the match block, and it will match against this first pattern. So it matches against none. And then the expression we get from that is also none. So that is the value of the match block. That then is the return from the function, and yeah, we then put that into a variable none there. Okay. So it's a way that we can take a variable and extract that from the sum and then refer to that in the expression on the right-hand side. Okay. I think what I'll probably do is to finish there, because there's quite a bit for you to think about. So do go through that carefully. Make sure you're okay with that, and then we'll pick this up again tomorrow. And then we'll continue with the lesson. We'll continue working on Rust.